All right, for questions 1, 2, 3, and 4, we're going to find either the intersection or the union. The intersection is anything in both sets, and the union is anything in either or both sets. So here we're looking at the intersection of A and B, so that's anything in both sets. So A is in both sets, and C is in both sets. So the intersection will be the set with A and C in it. Number 2, we're looking for the union, so that's anything in either set. So all the numbers in A, so A is in A, B is in A, C is in A. A and C are both in B as well, but D and E are also in B. So it's everything all together, anything in either or both sets. A union C will be anything in either set A or C. So we have A is in A, B is in A, C is in A, D is in C, F, and G. And then A intersect C will be anything in both A and C. So A is in both A and C, and that's it. So it'll just be A. When we write this in set builder notation, we're talking about all the numbers between -3 and 5. So the numbers, if we graph it on the number line and we put -3 here and 5 here, then we'll start at -3 and go all the way to 5. We'll have parentheses at 5 and a bracket at -3. So this does not include 5, and it does include -3 and every number in between. So the set builder notation will all be all the numbers x. These numbers x are bigger than -3, so greater than or equal to -3. So x is greater than or equal to -3, or the numbers that are less than 5. And it'll be less than because we have the parentheses there. So now if we graph this set over here, this is going to be -2 to infinity. So we'll start at -2, we'll have a parentheses, and we'll go to positive infinity. So these are all going to be all the numbers that are bigger than -2, all the numbers that are bigger than -2. So in set builder notation, this will be all the numbers x that are greater than -2. There's no equal to because it's a parentheses. On this graph over here, we'll put 0 on the graph, and now we're going to negative infinity. We'll have a bracket here, so we're going to negative infinity. So now these are all the numbers that are less than 0, right? All the numbers that are less than 0. So in our set builder notation, this will be all the numbers x, such that x is less than 0. Well, less than or equal to 0, because we have a bracket. So for these, we're going to find the intersection and the union by drawing both sets on the graph. So we'll start with the set -2, 1. And we'll draw this graph. So this will be open parentheses at -2 all the way to 1, bracket. And then we'll draw -1, 3. So it'll be -1 and 3. And let's draw this one in red. So this will be from -1 all the way to 3, open at 3. And now since we're looking for an intersection, we're looking for where they overlap. So where both of the sets are, and that's all this space right here in the middle. So where they overlap is from -1 to 1. So we want to write this in interval notation because it said interval notation. So this is all the numbers between -1 and 1 are in both sets, including -1 because that's a bracket, and including 1 because that's a bracket. So now we'll draw the two sets over here. So we'll have -2, -1, 1, and 3. We'll draw -2 to 1, parentheses on 2, bracket on 1. bracket on -1, parentheses on 3. And now for the union, we're looking at anything that either set touches. So anything that's in either set. So anything that any of these sets touch. So that'll be anything from -2 to 3. That's what we're looking at. So we need to write that in interval notation. So we'll write this as -2 with a parentheses, because there's a parentheses on -2, all the way to 3 with the parentheses because there's a parentheses on 3. Do a few more here. So we'll graph this one. We have 1, 0, and 3, and 4 on this number line. So first we'll graph the first set, 1 to 3. Then we'll graph the second set, 0 to 4. And now we're looking for a union, so anything that either set touches. So that's everything from 0 all the way to 4. Anything that either set touches. Again, we're writing it in interval notation. So from 0 to 4, putting parentheses because there's parentheses on 0 and 4. So in this interval, we'll graph -1 to -infinity and 3 to infinity. So -1 to -infinity will be a parentheses and then going to -infinity. And then this one will be 3 to infinity with a bracket. And we're finding the union. So this interval, well, it will just be everything that either one touches. So it's really just the answer is what we started with originally, because it's everything that either set touches. So it's -infinity to -1, union 3 to infinity. So it's really just what we started with, because it's anything that either set touches. So now we're going to determine if these relations are functions. So we're looking for no repeats in the domain or x values. So remember, the domain is the x values. So here we'll look at the x values. There's no repeats, so this is a function. Here we'll look at the x values. There's no repeats, so this is a function. And here we'll look at the x values, and there is a repeat, so this is not a function. Then we'll go back here, and we will, sorry, let me move this around. We'll list the domain and range, because it also said to give the domain and range. So the domain will be all the x values, so 2, 3, and 5. The range will be all the y values, and that's just 7. It's okay to have repeats in the range. Remember, that's fine. It can still be a function. So here our domain will be all the x values, 1, 2, and 13. And the range will be all the y values, 10, 500, and pi. And this is still a relation, even though it's not a function, so it still has a domain and range. So the domain will be all the x values. So that's 12 and 14. And the range will be all the y values. So that'll be 9, 13, and 15. Now here we're looking at the graph to determine if it is a function or not. And that's where you want to look for if it passes the horizontal line test. So imagine drawing horizontal lines, and if at any point it intersects it in more than one point, so like right here, this intersects it in 3 times, then it's not going to be a function. Whereas over here, if we draw a vertical line anywhere, it only intersects the function once, so this is a function. All right. So now we're going to evaluate the function at some values. So here we will find first f of 4. So we're going to replace the x with 4. So anywhere there's an x, we replace it with 4. So 5 times 4 minus 7. That'll be 20 minus 7, or 13. this part here to find f of x plus 3. We're going to replace the x with x plus 3 now. That's what's in the middle. So this will be 5 times x plus 3 minus 7. We'll distribute the 5, so we'll have 5x plus 15. Still bring down the minus 7. Combine like terms here, so we'll get 5x plus 8. That's our final answer. And then here we're plugging in negative x. So f of negative x, we'll plug in an x, negative x where there's an x. So we'll have 5 times negative x minus 7, and that'll be negative 5x minus 7. Those cannot combine, so that's it. Now for this one here, for a, we're going to plug in negative 2. So we'll have 3 times negative 2 squared minus 5 times negative 2 plus 2. Negative 2 squared is 4, so we'll have 3 times 4. Negative 5 times negative 2 is positive 10, and we still have the plus 2 at the end. So this will be 12 plus 10 plus 2, which is 24. So for b here, to find g of x minus 1, we're going to plug in an x minus 1 wherever there's an x, here and here. So we'll have 3 times x minus 1 squared, minus 5 times x minus 1 plus 2. Now this part here you have to be careful. So first we have to do the square. You have to do the exponents before you multiply. So we need to do the square first. So we're going to multiply x minus 1 times x minus 1 first. That's what x minus 1 squared means. It's multiplied by itself. We can distribute this, so we'll get negative 5x plus 5 plus 2. And then when we multiply x minus 1 times x minus 1, we have to distribute. So we'll do x times x. That'll give us x squared. We'll do x times negative 1. That'll give us negative x. We'll do negative 1 times x. That'll give us negative x. And negative 1 times negative 1, which will be positive 1. And all of that is being multiplied by this 3 in the front. So that's where you have to be careful. Then we can bring down the rest of this. And then we can multiply the 3 by everything in there. So we'll have 3x squared minus 3x plus 3 minus 5x plus 5 plus 2. Combine like terms. There is nothing to combine with 3x squared because it's its own term. So then we can combine negative 3x, and negative 5x. They just combine as is. So negative 3 minus 5, that'll be negative 11x. And then we have the constants, 3, 5, and 2. Those are all positive, so those will become plus 10. And that is our final answer for B. Now this one's a little tricky because it's negative g of x. So instead of plugging in negative x, this is literally just g of x with a negative in front. So g of x, remember, is this right here. That's g of x. So we're just going to take that and stick a negative in front of it. So that's different than g of negative x, just FYI. So we're going to take g of x and just stick a negative in front of it. So it'll be negative 3x cubed plus 5x minus 2. All right, here for number 19, we're looking for the domain and the range. As well as increasing, decreasing, and some function values. So we'll start with the domain. Domain is the furthest value to the left and the furthest value to the right. So this function, the furthest value to the left is negative 3, and it's included because it's a closed circle, and the furthest value to the right is 5, and it's not included because it's open. the range will be the highest value and the lowest value. The lowest value is -5, because that's as low as this goes. And then the highest value is up here at 0. And it does reach 0 because of this closed circle, even though there's an open circle there. So it will be closed. So when the function is increasing, we'll just trace along the whole thing. So here, we'll start here. This is decreasing, going down. And then it switches to increasing right here. And then it starts going down again for decreasing. And then it switches to increasing. So then we need to describe the increasing intervals. So the increasing interval, the x value here is -2. And the x value where it stops is 0. So that will be from -2 to 0. It's open parentheses because it's only at the ends that you'll ever use close parentheses for increasing or decreasing. Another interval where it's increasing is from here to here. The x value here is 3, and the x value here is 5. So 3 to 5. For decreasing, we'll look at the green intervals. So the x value here is -3, and then where it stops is -2, so that'll be -3 to -2. The -3 is the one place where we can have a closed interval. If you put an open interval there, it wouldn't be the end of the world, but most of the time you'll see that as a closed interval. And then the next green is from here to here. The x value here is 0, and the x value here is 3, so that'll be 0 to 3. And then there's nowhere where it's constant or straight. When f of x is less than -4, that's talking about any value of the function that is less than -4. So if we look at a y value of -4 right here, all of this part's right here, the function is less than -4. So that'll be from 2 to 4, because the x values there are 2 to 4. And then to find the function values for f of -2, we will look at where, remember this is the x value, so we're going to look at where x is -2 and look to where our function is. So our function is right here, and then the output will be the y value. So there the output is -3. Then when x is 3, the function is down here, and we'll look at the y value, that's -5. All right, now if we look at number 20 over here, the domain, this function goes forever this direction and forever this direction. So to the left, there is no beginning, and so that'll start at -infinity. And to the right, there is no end, so that'll go from -infinity to infinity. For the range, the lowest y value, again, it goes down forever. So the lowest y value, there won't be one, so it'll go down forever to -infinity. But the highest y value is at 3. So the end of the range will be 3. It's included because it actually does reach that point. There's no open circle there. So now let's do increasing and decreasing. So we'll trace along the function here. We'll start with where it's increasing. So it's increasing to start, increasing. Then it gets up here to the top and it starts decreasing. So our increasing interval, there is no starting point because this goes down forever. So our increasing interval will start at -infinity, and then it ends right here, which the x value there is 0, not 3. 3 is the y value. We always want to use x values. And then the decreasing occurs starting at that x value of 0 and all the way to infinity. There is nowhere where this is constant. And if we're looking for values where f of x is greater than 0, we're talking where the y values are greater than 0. So we're talking about when y is equal to 0, that will be here. So we're looking for all the values that are greater than 0, so that's this interval right here. So that's -2 to 3. Then if we're looking for the function values, here, f of -2, when x is -2, our function is actually right here, and the y value there is 0, so it's equal to 0. When f is 6, that's right here. The function is going to be right here. You can see the arrow pointing there. So that will be -3 will be the y value there. And for 21, if we look at the domain, this function, the furthest left it goes will be -infinity because it goes forever. And the furthest right it goes is +infinity. The range, though, the function does not go down below -2. That's the lowest that it goes is -2. So the range will start at -2. And then the highest value the function goes, y value is 2, so it will end at 2. For increasing and decreasing, well, it starts off constant here, then it switches to increasing, and then it goes back to being constant. So for increasing, it's increasing from here to here, which is x value of -2 to x value of 2. Oops, sorry. Should have a parentheses there, no bracket, because it's not on the end. And it's decreasing nowhere. And then it's constant on these red portions. So it's constant, it starts at -infinity. And then it ends at the x value right here, -2. And then it starts again at the x value 2 and goes to +infinity. And if we're looking for where f of x is less than 0, we're looking for where the function is less than 0. So we're looking at the y values less than 0. So this is where the function is equal to 0. So everything less than 0 will be all of this. And so that will be from -infinity to 0. Then if we want to find the function values at -9, well, you might be like, I don't know, because -9's not on here. But we do know what this function does, right? It keeps going like this. So at -9, somewhere out here, the function will still be here at -2. The y value is -2. And same thing in this positive direction, it keeps going. So even though it asks us for f of 14, when the x value is 14, somewhere out here, we know the y value will be 2. All right, and lastly, let's do a couple of piecewise function examples. Remember, for piecewise functions, you need to use this part here to decide which of those functions you're going to plug in your x value. So for example, when x is -2, that is equal to 2, and this bottom one says x is greater than or equal to -2. So that's equal to -2, so we'll use the bottom function. So we'll plug -2 in for x in the bottom function. So this will be -4 minus 1, which is -5. When x is 1, that is greater than -2, so we'll still use the bottom function because that's when x is greater than -2. So we'll plug it into 2x minus 1 as well. Plug it in for x, and you get 2 minus 1, which is 1. Then for 4, that's when x is greater than -2 as well. So that's still going to be the bottom function. So we'll still plug that into the bottom function. So that'll be 7. For the next piecewise function, when x is -2, that's less than 0, so we'll plug it into the top function. So we'll plug -2 into x minus 6, so we'll get -2 minus 6 will be -8. When f is 0, when x is 0, we use the bottom one because this says x is greater than or equal to 0. When it's greater than or equal to 0, ours is equal to 0, you're going to use this function. So we'll plug in there, -2 times 0 plus 1. -2 times 0 is 0, plus 1 is 1. And then when x is 3, that's when x is greater than 0 again. So that's this one. So we'll still use the bottom function. So we'll plug it in there, -2 times 3. plus 1 will be negative 6 plus 1, which is negative 5. And lastly here, for g of 0, when x is 0, this one here says we use the top one because this is x is less than or equal to 0. So we'll plug it in here for 2x. 2 times 0 is 0. And then when x is negative 6, that is still less than 0. So we'll still use this one here. So it tells us to plug it into 2x. So that'll be negative 12. And then when g is equal to negative 3, let's make this one a positive 3, just for fun. Let's say this is positive 3. When g is positive 3, let's say it's positive instead of negative, then we would plug it into the bottom one, right? And so then you would get out 2.